going to start recording. Afternoon, ladies and gentlemen. Welcome to Lecture 8, the Introduction to Inheritance. Just to check if anyone online has any questions about composition, please post them. I can answer them briefly, but I want to start with the new concept of inheritance. It's not a difficult concept, but it is something that's going to take a bit of time as you've got lots of different areas to cover. So we're going to start with the basics and then work through. It is one of the 4 principles of OOP. Remember, encapsulation, abstraction, inheritance, and polymorphism. So now we're discussing the third one in detail, inheritance. Composition is part of OOP, but it's not one of the 4 principles of OOP. So it's something that comes out of object-oriented programming, but it's not a principle of OOP. So let's start with today's lecture. Also, an announcement, I've found out from a colleague that I can upload the compressed versions of the tutorials to Blackboard, so I'm doing that as well. So if you want to download the tutorials in a smaller format, they'll be on Blackboard hopefully by the weekend. I'm currently encoding them all to a lower resolution, so a bit less data intensive. Again, make sure you upload your practicals in time for Friday and upload your designs. Also, make sure if you want feedback on Friday, you're on Discord within the first 20 minutes of the start of your session, so the assistant knows you are there, and let them know you are there. Okay, but again, if the assistants have load shedding, unfortunately, there's nothing we can do. They will mark you and get back to you as soon as they can with feedback. We're looking at a new way of doing feedback as well. Hopefully, we'll explain that tomorrow in the class. I'll show you how to look for your feedback. So you guys have a bit more access to feedback, especially those who are not able to access the live sessions. But please make sure you upload your practicals. And remember, ladies and gentlemen, your semester mark and your PCM have to be on the right levels to get into the exam. And your PCM, your practical component mark is your semester test 2 and your weekly practicals, as you've calculated them for practical 5. That's a calculation that is actually what we use. So just remember that as well. I think that's all the announcements I have. So let's start going into the general knowledge as normal with the first lecture. We're looking at security keys and password vaults. Yes, someone's raised their hand. You have a question. You can unmute yourself. Okay. I don't know where that person's gone. Okay, maybe your mic doesn't work. Okay, so we're looking at security keys and password vaults. Does anyone know what a password vault is? Password vault. Sorry, let me get the right pronunciation. Has anyone heard of a password vault before? Yes, no, in chat? I don't know. Yee. Got some yeses, some no's. That's scary. Okay. Please don't tell me you all use like, okay, I've got a bad feeling now. Don't tell me you use like one password for everything. I should even ask for feedback on that. Because that'll just like, yeah, okay. Okay, those who do, and those who are listening in on the recording and those in class, try and make sure you at least have different passwords for different sites. A password vault is designed to store all your passwords. So what happens is you have one password, which is your master password, which gives you access to your password vault, which stores all your other passwords. So, and it generates passwords for you as well. So it's more secure in that sense that it'll generate a password for you. Tools that you can use are like LastPass. There's a whole bunch of them that can plug into your browser and store your passwords. Now, on top of having a password vault, you get something known as a security key, which is this USB device on the side here. Anyone seen that before? Some of you have, some of you haven't. What that is normally Pacific companies sell them. It is a unique ID'd USB. The USB can't store information. It's not designed to store anything. It's designed to have a very, very unique password on it. So on top of a password vault, you can use the key as a two-factor authentication mechanism to secure your accounts. So instead of just having a password, you have a password and this key that you put into your computer to say, yes, I am the right person. So remember, two-factor authentication is built on the idea of something you are, or something you have, and something you know. Generally, you can think of it like that. Two-factor authentication is something you know and something you have or are. In the case of going onto campus before COVID-19, what did you have to do to go onto campus? Fingerprint. Okay, fingerprint and card access. Sanitizer, yeah. Student card, and then you would swap your thumb. Okay, that's two-factor authentication. Something you have and something you are. So that's two-factor. You also get two-factor on your Google account. You can get two-factor on a lot of accounts. Your banks should have a two-factor authentication at least. But the benefit of a password vault, what happens if you lose the key? You're screwed in some sense. With two-factor authentication, there's always a backup authentication. In the case of I know in some cases of a password vault, if you forget the master password, you lose all the data. So the key has one password. The key is a password itself. Any way to bypass it? Not really. If you set your system up correctly, there's no way to bypass it. You have to have the key and you have to have the password. It's a way to make things more secure. Okay, for example, my Dropbox, to access it, I need to know my password, I need to have my USB key. If I don't have both of those, I can't access my Dropbox. To access my password vault, I need my password and my key. So no one can access my password vault either because they need my key. So it provides another layer of protection to your system or to your personal information. Or for security purposes, yes. They range in prices. I can't remember how much the YubiKey that Mr. van der Westhuizen mentioned. Unfortunately, it's not sold locally, it's imported. So it's in the dollar range. But they're slowly moving into South African markets, so they are going to become available. But it is a way to add security to your respective accounts. Especially, look, everyone hates memorizing passwords. So what happens is you generally use the same type of password or a similar password for all your accounts. Problem is that leads to the chance of your password being leaked and then being used somewhere else. So it's important to try and make unique passwords for your more important websites. Your bank account, your student account should have unique passwords. Your email account definitely should have a unique password. Because that is because if you have access to your email account, you can do much more damage. Is it 100% safe, so the USB key? No. There's no such thing as 100% safe in computers and security. There's always a risk somewhere along the way. So you have them both, or do you have at least one of them? I have both. I have both the key and a password. The key is an encrypted string of information, yeah. Okay, it's just things you can look at as you go. We're also trying to give you a bit of general knowledge in the field. So people are moving to the fact that they can use this type of approach to secure the information. It's a unique way of doing it, but we've spent enough time here. Let's move on. Always can come back. Okay, so what is inheritance? What should we use inheritance? When you should use it? Implementing what does inheritance objects look like, and protect it. So hopefully, I don't think we're going to cover all of this today. We're going to finish it off tomorrow. I want to get through the basic idea of what inheritance is. It's a very useful thing. So what is inheritance? If you think in a biological situation, I've got the example I've got here is, I must just give, I don't know if that's the right link for the image, but it's showing you how you get your blood type. So based on your parents' blood types, you'll receive a certain blood type. You inherit qualities from your parents, correct? Whether we like the qualities we inherit, we get them nonetheless. Going bald, having to wear glasses, etc. Those are the qualities we genuinely inherit from our parents. You can also inherit other qualities from your parents, your eye color, etc. So inheritance in IT is built on a similar idea that we inherit code. We inherit qualities of other objects or other classes. Does that kind of make sense, ladies and gentlemen? Guys are going quiet a little, okay. Okay, so you're clear with the idea of what inheritance means. Got to know there. Okay, think about it. When you're born, do you get to decide your eye color and your hair color and your skin color? No. Okay, we don't get a decision on that fact. We are just born and then we get given qualities. The qualities we get is based on who our parents are. Okay, their eye color, their skin color, their hair color, their type of hair. In this case, the example is of their blood type will dictate what we get. So using that idea, inheritance is about reusing code. We inherit functionalities from other code. We inherit attributes from another class. So the idea is the same as a biological. We inherit qualities from our parents, but it doesn't work in reverse. Keep that in mind. Here is the child at the bottom here. Just get that screen up. Okay, I need my laser pointer. So a child. Okay, now let's talk about you guys, for example. The fact that you know how to program now, does it mean your parents can program? Okay. So inheritance doesn't work backwards. It doesn't go back up the chain. So you inherit qualities from your parents which come to you, but you can then specialize and add qualities to yourself in a sense. Okay, so that's part of inheritance as well. So every time you step down in inheritance, certain qualities are sometimes added as well, or specialized. So the idea is not to reinvent the wheel. We've got the wheel already. Why do we have to go and make it again? And there's actually a quote. The standard library saves programmers from having to reinvent the wheel. This is what we're going on about. We don't want to redo things. We don't want to redo functionality. We want to reuse functionality. And inheritance is one way that we're allowed to reuse functionality quite efficiently. So let's look at the example here. We have a plane. Is a jet plane a plane? Okay, I see we also have the creator of C++. Thank you for pointing that out. Okay, so everyone agrees a jet plane is a plane. So a jet plane will have cockpits, it's going to have seats, it's going to have a gallery, and it's going to have a toilet, correct? Because that's what inheritance is. A jet plane is a plane, so it inherits all of this functionality plus this. Okay, inheritance is ability for us to say that this class is another class. It inherits its functionality, its qualities, and can add to it. Generally, when you go down in the inheritance hierarchy, you specialize. So from a plane to a jet plane. So all thumbs are fingers, but not all fingers are thumbs. Yes. Okay, so you can classify a lot of things as planes, but not all planes are a jet plane. We're going to go through a few examples with this to try and explain to you guys how it actually fits together. But the idea of inheritance is we group together common things that can make up a parent. Because what we're looking at now is the parent class and the child class, or the base class and the derived class. There's two ways to refer to them. You either have a parent or base class, or you have a child slash derived class. A jet plane is derived from a plane. A jet plane is the child class of a plane. So it inherits its qualities and attributes from a plane. So how it looks in terms of composition and inheritance. We had our plane has seats. This is composition. Everyone okay with this? That a plane will have seats. Now, if you look over at inheritance, a jet plane inherits plane. And we have the is-a relationship. So is a jet plane a plane? Okay, it makes logical sense. Is a seat a plane? Okay, so you can see the difference between composition and inheritance. A seat cannot be a plane. A seat has plane. A plane has seats. It's an object in a plane. Yes. Okay. So it takes on the characteristics of a plane? Yes, it does. So a jet plane takes on the characteristics of a plane and adds to it. So we're going to look at the example of two shapes. Okay. We have a triangle and a rectangle. They both have values A and B, and they both have a calculation to calculate area. So we would have the two UML diagrams like this, correct? To represent a triangle and a rectangle. What is in common? Area, A and B. Okay, so we can then create, and this I'll look in the code for triangle and rectangle. So if we look at them, they are almost identical except with the calculation of area being different. Except for that, they're almost identical in the attributes and the fact that they can calculate an area. So they have common qualities. So what we do is we group the common qualities into a base class, which is then shape. Shape has A and B. It has the property methods for A and B. It doesn't yet have the calculate area. We're going to get to calculate area and how to add it in later. Right now we can't, because I haven't taught you how to do that yet. So we have our base class shape. Then what we do is we have triangle inherit shape and rectangle inherit shape. Do you see any declarations of A and B inside these two classes? In the triangle, is there any declaration of A and B? In the rectangle, is there any declaration of A and B? But if you look at the code to calculate area, is it referring to A and B? Okay. It has access to the variables A and B because they are part of the parent, part of the base class. Okay, and there's actually a mistake in this code. I've just seen it now. Any idea? Anyone who wants to guess what the mistake is? No. Should be public. No, we can't have it public. There's another thing we can call it. But this A and B should actually be AB, not A underscore B. Correct. You should use the property methods. So you should be using the property method AB instead of the underscore AB. I'll make adjustments to the slides and then upload them again. So keep that in mind. But we don't have the property methods or the instance variables for A and B. This is the point. We inherit them from shape. So shape has the property methods. It has that functionality. The rectangle and triangle inherit that functionality. It inherits the property, anything that's public or protected, which we'll discuss either today or tomorrow, depending on our time. Anything that is protected also is inherited and accessible. So why don't we have setters and getters? Because there's not enough space on the slide. So I might update this to show you the getter and setter. But if I did it, there wouldn't be enough space on the slide. You would normally have your getter and setter. Okay, please keep that in mind. I might update the slides to reflect that. It's just, it gets the font gets a bit too small when you start doing too much in the code. So sometimes we will leave out certain sections of the code just because of spacing on slides. But I'll see if I can update that. But is everyone okay with the fact that we don't have to declare A and B again inside triangle and rectangle? Do you guys get that idea? Okay, good. Okay, for those listening in on the recording, please, if you're not sure what we're talking about, hit Discord or hit YouTube on commenting and say you're not sure so we know to cover it again. But the idea of inheriting is, since it's in common, we can take the common qualities, join them together and make a base class. And then the thing is, if I need to add another shape, say a circle, now would that work? Circle has radius and nothing else. So a circle wouldn't really work with this calculation because it doesn't have A and B. But you could add another shape that also works with A and B. Could you add a square? You could add a square. It allows you to add things. A rhombus. I don't know what a rhombus is right now. Allows you to add functionality. So a base class is basically the parent type class, yes. We inherit all the qualities of shape into triangle. So triangle is a shape. So any object created of triangle is also an object of shape. If that hopefully makes sense. So in UML, it will look like this. We would represent the shape, its attributes, its property methods. Yeah, you can look at it as a mother also. Parent, but in VB, we're limited to one parent or one base class. So you can't have another base class. And some languages allow for multiple inheritance. VB doesn't allow for multiple inheritance. It has another way of doing it, which we'll discuss later. But VB is limited to one base class. Each base class or parent class can have as many derived or children class as required. So you'll notice we don't declare A and B again inside rectangle and triangle. Okay. Good question in terms also both rectangle and triangle call a method called calc area. Has the same name, but it belongs to different objects. There's a better way of doing this. We'll discuss it later. There's a better way of doing this, but I can't show you right now until you understand inheritance. So we're going to go step by step with this. So there is a better way of handling this type of situation, but we need to actually cover it first. Right now, let's just understand inheritance. You access A and B through the property methods, correct, in terms of these two classes. So rectangle and triangle don't need property methods. Okay, they have property methods already from base class, their parent class. So it has access to whatever's public. So these two are public, so these ones have access to it. So in the UML, you'll just have to include the methods, correct? Only what is different is included. You don't include it again. So say, no, you have to create objects. No. Okay, I'm getting off topic, going a bit. So in inheritance, we don't have to create an object within a class. No, that's composition. How many classes we have now? 3. We have 3 distinct classes. We have class shape, class triangle, and class rectangle. So can you only inherit from the base class? Correct in this situation. You only can inherit once. So each class can inherit from one base class. Okay. There is another class on top of shape known as object, but I'll discuss that in a later date. But as long as you guys understand the point that triangle and rectangle inherit or is a shape and get the qualities of shape, you've got the basic idea of inheritance. Okay? Because inheritance is the key fact that we inherit from a base. Can we have composition and inheritance at the same time? Yes, you can. There's no restriction on that. But let's just focus on inheritance for now. Let's get the idea of inheritance. Is everyone comfortable with the idea of inheritance that are attending live now? Yeah. We'll get to the keyword now. I'll show you the implementation. Okay, looks good. Okay, so going back up, there's the keyword. This is how we know we inherit. Is underneath class, directly under the name of the class, we type inherits shape. That's how we indicate inheritance. That under the class, directly under public class, we go inherits shape. No, it's not equivalent to sharing. Sharing something else. What happens is it gets a copy. It gets its own variation of the information. It's not shared. Please don't get confused with shared in that. Shared is something else. I know in terms of English, we're sharing the variable information, but it's not in VB. Just be careful with that point. What happens is triangle will then gain. It'll inherit property A, property B. This one will also inherit property A, property B. So it has access to these variables. Let's have a look at another example. Okay, this is give you bad memories of your practical 5. We have the example of a UJ program for UJ. We have the class Business Management 1A. Has a semester mark, semester test 2, assignment, exam, and we calculate semester mark entrance, evaluate exam entrance, and calculate final mark. Then we have Informatics 1A, also has semester test 1, semester test 2, practicals, exam mark, calculate semester mark, PCM, evaluate, calculate final mark. Then we have Mathematics 1A, also semester mark, class test. If we look at these all together, what are the common properties or common attributes? Let's start with attributes. What are the common attributes? Semester marks and exams, semester test 1, semester test 2. Now, we have semester test 1, semester test 2, semester test 1, semester test 2, semester test 1, semester test 2, and we have exam. Those are the common. Then if you look at our methods, we have calculate SM, calculate FM, and calculate exam entrance. So those are our common attributes and common methods. So we can take them and form a base class with the common qualities. And then have the inheritance linking up. Okay, so we then have inheritance linking up to the different modules. So UJ module is now the base class. And then informatics, mathematics, and business management 1A all inherit from UJ module. And all we do is the different functionality. Like this one had a class test, this one had a practical, this has a assignment. So those are the extra attributes that these ones have. Informatics 1A has a practical component mark, so it has an extra calculation that isn't part of these 3. Okay. I just want to go back up and double check something. Okay, also keep in mind that the calculate semester mark, is it the same for all of them? But how would we implement the methods and link them from the base class and the derived class? We'll show you. If we look at the semester mark, it's calculated differently in each instance. It's got to be something that is altered slightly, so we have to look at the different calculations as well. So I'll do the implementation with you on Thursday. Right now, I just want to do the theory behind it. How many attributes does Informatics 1A have? Got one answer. 4. Correct. Okay, good. Informatics 1A has 4 attributes. It's not limited. It has 4 attributes. Okay, because it has its own practical and it inherits semester test 1, semester test 2, and exam mark. It inherits those functionalities or those attributes. So it inherits those attributes. So it's not just practicals, it's all of them. The mother or the father, yeah, you can consider it that. But just be careful when you're writing in a test, use the right terms. So it's the base or parent class. How to implement it. Okay, so we would have, these would be this is our base class. Again, not all the code is here because space limitations. Okay, so we have our private variables, our property methods, and our public functions. Then we would do our practicals and calculate PCM. The difference would go here. Okay, so before I move on, I want to make sure you're comfortable here because we've got one last section of the set of slides to cover. We're going through a bit faster than I expected, so I want to make sure you guys are comfortable with the idea before we move on too quickly. Because I expected someone to maybe get stuck with the other ones. So is everyone okay with what's happening with shape? Everyone understand that you can have triangle, rectangle inheriting from shape? Okay. Good. Again, for people watching the recording, please let us know on Discord or on YouTube if you're getting stuck somewhere so we know we have to emphasize the concept again. Now, when it comes to the UJ module, we find the common qualities and we start pairing them up. So we pair up the common qualities and make our base class, which is then the UJ module as you see in front of you now, with its variables, its property methods, and its functionality. We then have our next class, inherit UJ module. So we don't need to go and declare all of this again. It's already there when it inherits. All we do is we declare the new functionality and new attributes. So we have practicals and we have the calculate PCM. Okay, so calculating PCM is done like that. And we can work out our practical component mark. Which one is correct though? Is this one or this one correct? Option 1 or option 2? Mind, look at that. Okay, option 2. Why option 2? Anyone? You're writing saying option 2, which is this one, using the property methods, correct? Okay, we don't access to the semester test 1 and 2 because they are private. Okay, so we have to access through the property methods. But what if we want to access directly? What if we don't want to go through the property method? What if we want to have direct access but keep it still secure? Some of you guys have mentioned the term before in class. We want to go semester test 1 and semester test 2, but we don't have a property method. Okay, those have maybe a program a bit before, you know the term called protected. So we have public, private, protected. Protected is a type of access control. Protected only exists in inheritance though. Protected only works with inheritance. If you look at how we're referring to semester test 1 now in the UML, you'll see you got a hash. That indicates that it's protected within the inheritance. So any child can access the inherited information that's protected. So we don't deny access when using protected. We allow access for child and derived classes, but no one else. Okay? Every family has normally a family secret or family history that not everyone's supposed to know about. Okay? Skeletons in the closet. Quick question. How many of you know your parents' credit card numbers or credit card PIN? Okay. Yeah, it's just depressing to watch every year. Okay. Now, do you share that PIN with other people? That's protected. Hell yeah. No, what the hell's wrong with you? Okay, hell nah. Okay. That's protected, ladies and gentlemen. It's known to the family, but no one else. Okay, I don't know if you guys seen that movie. Protected is within the family. You keep it within the family. So only derived classes have access to protected. So with protected, it allows us to access a variable directly without going through a property method. Okay. But a lecturer, I have no inheritance to UJ module. I do not have access to the shared variable at all. I cannot see the shared variable. Only in classes that inherit have access to shared information. Or, sorry, not shared, protected information. Only ones that have inherit have access to the protected information. So it stays within the family. You guys okay with that point? Okay. Let's see if we can do a bit of coding in the last 5 or so minutes. Okay. So let's go back to shapes. Okay, I'll say it again now. Let's go back to shapes and do it properly. Add class shape.vb. It has a protected. I'm going with protected now because I want to make use of a as integer. Protected. Actually, let's make the other one private so you guys can see the difference. I still need my property methods. Ah, So I got a triangle. I don't need all of that anymore. Okay. I still need to copy and do one copy paste. And we say inherits shape. Okay. Now I inherit everything that is part of shape. So I can have my public function calc area as double. My triangle is, what's the calculation for a triangle? Triangle AB times divided by 2. Okay, that's fine. So let's go hit the code again. So it returns A times B divided by 2. Now you'll notice that A is not being underlined, but B is. A is happy, I can use it, because it's protected. B is private, so I can't use it. So if I want to use B, I have to use the property method, B. Because protected is allowed within the inheritance. This is a child class of shape. It's a derived class of shape. So it can access any protected information, but it can't access the private. Private is still private. Okay. You'll get the same result though. Yeah. If both were protected, then I'd access B directly. So if it was also protected, then I'd have direct access to B. Because it's protected as within the family. Okay. Problem is I have an example of private, but this is being recorded, so I don't know how much trouble I'll get into. That's good. Certain things are private to parents, correct? Do you want to know what your parents get up to late at night by themselves? See how long it takes you that to sing. One person's got it. Okay, you don't want to know what's happening, correct? That's private. Okay, now you understand what private is. Protected is some things that you do know, they have direct access to. If it's private, it's still private, they're sleeping. Okay? I knew I'd get a reaction from that comment. Okay? So protected means you have access direct. If it's private, though, it's still private regardless of inheritance. Whatever we're doing, it's still private. It's limited. Protected means you have access to it if you're inheriting. So if I go to the form, just to show this again, and quickly make a private sub example, and I go instantiate a shape dim shape as shape shapes equals new shape. If you notice, I don't have access to A and B directly. I have access to AB, the property method, but I do not have access to underscore A or underscore B. They still are private because the form does not inherit shape. It doesn't have direct access. A triangle inherits shape, so it has direct access with a protected involved. Does that make sense? Since I've mentally scarred some of you, I'm hoping to get some response still. Okay. With triangle, I have direct access to the instance variable _a_b because they are protected. Everyone okay with that? But when I go to the form, I don't have access to _a_b. I have access to a and b. That's it. Why? We'll get worried about the construct in a few minutes. I'm focusing on why we don't have access to _a and _b in the form. In the form, you have access to the property methods, not family, correct. I have access to the property methods, not part of the family, correct. Form is not inheriting, excellent, excellent, excellent. Form does inheritance and they are protected. So you see where protected fits in. It works with the classes that are inheriting, but it doesn't work with the classes that are just being used, we're using. So the form class is implementing, instantiating the objects, but it's not part of the family, so it doesn't have access to protected. However, triangle is part of the family. It has access to the protected. Okay, and I'll discuss more on this on tomorrow's lecture. Don't worry. Only derived classes have access to any protected? Yes, only derived classes have access to protected. That's why protected only exists within inheritance. That's why we've never discussed it until now, because it only works with inheritance. So inheritance is the key to allow protected to work. So that's why we had to make sure we've covered inheritance, then we cover protected. We're still going to cover overriding and overloading, all sorts of other unique tools to inheritance that makes it a lot more useful as we move on with our building coding abilities or building your tool set to code. So there's a lot more to cover, but I think that's enough for today as we run out of time. Is everyone okay with the idea of inheritance? I'll recap it tomorrow again, and then I'll go into more detail. Okay. Hopefully I haven't mentally scarred you too much today. Okay, I'm going to stop the recording. If you have any questions, you can ask them